hello everyone. Good afternoon. So welcome to Board Brahmastra, and today we are going to start with the electricity chapter. I know a lot of you are very curious and waiting for this chapter. This is a bit difficult because it is not very intuitive. Why current will flow in such a particular direction? Why there is a voltage? Why there is potential difference? These are not like, we don't use these terms in daily life. Correct? So let's learn it properly from the basics. So welcome all, and let's begin. This is about me. I have done PhD in physics from National University of Singapore, BSMS dual degree from IISA Pune. I was ranker in IIT JEE Advanced. So there's a star question, and I'm quite sure, I can guarantee you, by end of this session you will be able to solve these kind of questions. So we'll come to this question at the end. So let's begin from the beginning. Let's start. So what is electricity? Hi, bunks. Yes, correct. So what is electricity? Is it like electrons, or is it something else? Is it energy? So electricity is the electrical energy. Electrical energy is the one which flows from one place to another place, and we use this electricity or the electrical energy. We convert this. It is the most convenient or the most suitable form of energy. We use it to convert into our required type of energy. For example, if you are using TV, so this electricity will get converted into light or sound. Correct? In heater, you convert this into heat energy. So this is the most convenient form of energy. So now, how do we produce this electricity? In grade 8, you must have learned that there are two types of charges. Positive charges or the like charges, they repel each other, and unlike charges, they attract. If it is positive and negative, they will attract. Both of them positive, both of them negative, they will repel. You have learned this, correct? So now, yes, like charges, they will repel, unlike charges, they will attract. And what is the origin of these charges? So you have learned atomic structure in chemistry. So inside the atom, there are three types of particles. These are called as subatomic particles. Inside the nucleus, there is a proton and neutron, and outside the nucleus, there are electrons which are revolving around the nucleus. So these neutrons, they do not have any charge, no charge. Protons will have positive charge and electrons have the negative charge. Correct? So now, solve this question. So out of those three subatomic particles, which charged particles are responsible for electricity, or which charged particles flow? Yes, come under the property of charge, correct. Yes, nice, all of you correct, awesome. So which charged particles in a metal or conductor, they move or they flow? You see, these are the atoms of the metal or the conductor, and you see this negative charge, they jump from one atom to another atom. So when there is electric current, these electrons will flow from one atom to another atom. So electrons are responsible for movement of the charges. The protons and neutrons, they are inside the nucleus. This nucleus, they do not move because nucleus is very small, it is very heavy. So it is very difficult to move the nucleus, but it is very easy to move the electrons. Okay, so now can you tell me the differences between conductors and insulators? Do you know which materials are called as conductors and which are called as insulators? So conductors are the ones which can conduct electricity. Insulators are the ones which resist, which stop the flow of electricity or flow of current. So now you can see silver, gold, copper, steel, even seawater, salt water, these are all good conductors of electricity. They can conduct electricity, and these materials such as rubber, glass, oil, diamond and dry wood, these are responsible, they stop the flow of current. They do not allow the current to flow. So these are called as insulators. Correct? Yes, nice. So now what is electric current? You see, if there is a flow of air, in scientific language we call it as air current. if there is a flow of water, water is flowing in the reverse. So we call this as a water current. So now if electric charges, they are moving from one place to another place, the flow of electric charge is called as electric current. Current is something which is flowing. So what is flowing? Electrons or electric charges, they are flowing. So it is called as electric current. So now what is the unit? We use a symbol either small q or the capital Q for the electric charge, and the SI unit for the electric charge is coulombs. But this coulomb is a very large unit. So we'll do one question, we'll solve one numerical, and I'll explain you why this is like a very big unit of current. Let's solve one question. Solve this question. So the charge on single electron is this much. On single electron. So how many number of electrons are required to generate charge of 1 coulomb? We want a charge of 1 coulomb. I want you to understand how big is this number. So 1 electron has minus 1.6 into 10 raised to minus 19 coulombs. We'll neglect the minus sign for now. We just consider the magnitude of this charge. Okay. So now we want the charge to be 1 coulomb. So how many number of electrons should be there? So how will you solve this? So X will be equal to, you need to do the cross product of these two. So X is equal to 1 divided by 1.6 into 10 raised to minus 19 number of electrons. These are number of electrons. So that will come out to be, yes, approximately 6 into 10 raised to 18. These many number of electrons are required for 1 coulomb of charge. You see, this is such a big number, correct? Now what is electric current? So electric current is defined as Q over T. So what is Q? Let's suppose there is our metal wire. There is a metal wire and the charge or the electrons are flowing through it. Electrons are moving through it. So if you take the cross section, any cross section, so how many number of electrons or how many number of charges they are crossing this cross section in 1 second? That is Q divided by time. In 1 second, how many charges are crossing this cross section? That is called as electric current. And we know the SI unit of charge is 1 coulomb, SI unit of time is 1 second, and the SI unit of current is ampere. So 1 ampere is 1 coulomb divided by 1 second. This is how 1 ampere is defined as. Okay? Great. So solve this question. Hello Shakti Ahmed. Shakil Ahmed, sorry. Yes, congrats. Nice. So electric current of 1 ampere flows in a time span of 1 minute. So what is the amount of electric charge flown? 1 coulomb? No, that is not correct. 1 coulomb is not correct. You see here the time is 1 minute. That is 60 seconds. The SI unit of time is seconds, correct? So we want the electric charge. We know I is Q divided by time. So Q is equal to current multiplied by time. So what is the current? 1 ampere. 1 ampere multiplied by time, which is 60 seconds. So this will be 60. Ampere into second is coulombs. SI unit of charge is coulombs. So answer is 60 coulombs. Option number D. Clear? Easy? Great. So now there is an electrical circuit. So in our houses you must have seen there is a light bulb or any electrical device. Then there is a battery. So we have the power cable. Power comes from the power station. But there is a simple, very easier to understand. This is a battery. For example, we have the radio or the torch. So in that we use this kind of battery, correct? So this battery is connected to the bulb and there is a switch. So you can close the switch or you can open it. If the switch is open, for example here, no current will flow through it. When you close the switch, current will flow. And what is the direction of current? This battery has two terminals. There is a longer terminal which is also called as positive terminal. The shorter one is negative. Current flows from positive when you close the switch and return back to the negative. This is how current flows in the circuit, correct? From the positive terminal back to the negative terminal. And any electrical devices, for example light bulb, can be represented by this particular symbol. We are going to learn about it in a very short time. So by the way, how many of you like or enjoy waterfall? Have you seen waterfall? I love waterfalls. I used to spend a lot of time under these waterfalls. So I hope you also like it. Yes, so now if you look at the waterfall, water always comes from top to bottom. It doesn't go from bottom to up. Do you know the reason behind it? Why water always come down? Why it doesn't go up? What is the reason behind it? You see here, there is a waterfall. Water comes from A to point B, correct? So if I define this point B as my ground, so you have learned gravitational potential energy. There is a ground level. So at A, will it be at a higher potential or lower potential? So which of the following is at a higher potential energy, point A or point B? Point B is lower, so it is at a low potential energy. Point A is at a higher, so potential energy at A is higher, correct? This one is at a lower. So water flows from higher potential energy to the lower potential energy. Do you know how to calculate the difference? What is the potential difference between point A and point B? That is our potential energy. If the potential energy at ground is 0, so at higher potential, so potential energy at point A will be mgh. You remember this? mgh, this is the potential energy, correct? So water flows from higher potential energy to the lower potential energy. So we have very similar concept in electricity. So what is that? This battery will provide the potential. So here we don't use a potential energy term, we just use potential. So this is the positive terminal of the battery and the negative terminal. So what battery does it? It push the positive charges. This is for the positive charges. Battery push the positive charges in the upward direction from the lower potential to the higher potential and across the resistor. For example, this bulb, this is also called as resistor. So across the resistor, what happens? The positive charges just comes down from higher potential to the lower potential. For example, here if I attach a motor, then we can pump the water to the higher potential. We need energy, right? The motor or the electrical motor to pump the water at a higher energy, and water will readily, easily flow from higher potential to the lower. So this across the resistance or across any electrical devices, the positive charges will readily flow from higher potential to the lower potential. Understood? Protons do not move because protons are inside the nucleus, and nucleus is very small compared to the atom. Let's suppose if the atom is the size of the earth, the nucleus is the size of the football. So it is that small and it is very heavy compared to the electrons. So protons do not move, and electrons were discovered much before the protons. So when they discovered the electric current, the scientists who discovered the electric current, they thought it could be due to positive charges. They didn't know, okay, it is the electrons which has negative charge. So they assumed that the protons or the whatever is the positive particles, they are moving. Later they found out, okay, sorry, we made a mistake. It is the electrons, not the protons or not the positive charges. So they just assume, okay, we say that the current flows as if there are positive charges. And if you assume that, okay, now we need to correct it because the electrons are the ones which are flowing. So electrons move in the opposite direction, opposite to the direction of current. Current flows from positive terminal when you close the switch and comes back. Electrons move in the opposite direction, opposite to the current. Correct? So there is a battery. So when the switch is on, bulb will glow. When the switch is off, bulb will not glow. So what is the purpose of the battery? To provide the potential difference across the bulb. Correct? So this is what battery does. It push the positive charges and provide the potential difference. So now what is potential? Electrical potential is defined as work done per unit charge. So what is electric potential? It is the work done to move a unit charge from one point to another. Let's suppose these are the 2 points, point X and point Y. So if I do a work of 1 joule to move a charge, let's say the charge is 1 coulomb. If I move the charge from X to Y and the work done is 1 joule, then we say the potential difference between these 2 points is 1 volt. So volt is the unit of potential difference. Correct? So how it is defined? 1 volt is 1 joule per coulomb. Great. So solve this question. Opposite to the current, correct? Electrons flow in the opposite to the direction of current. Correct. Nice. We'll come to that. This is going to be long session, but very important, very basics, and we'll go to the highest level possible. So how much work is done? We need to calculate what is the work done. In moving a charge of 2 coulombs, so charge is 2 coulombs across 2 points having the potential difference of, so voltage or the potential difference, I'll use this word, potential difference. It is how much? 12 volt. So we want to calculate the work done. So we know the voltage or the potential difference is work divided by charge. Correct? So the work done would be potential difference or the volt multiplied by charge. So what is the voltage? 12 volts multiplied by charge, which is 2 coulombs. So this will be 24 joules. So work done would be 24 joules. Clear? Easy? Okay, great. So you see, there is a direction of current. Current flows from the positive terminal and comes back, and electrons, they flow in the opposite direction. If current is clockwise, electrons will flow in the anti-clockwise direction. If current is anti-clockwise, electron will be just opposite. You don't have to worry about direction of electrons. We don't have to worry about this. You just focus on the direction of current. In all the electrical devices, just focus on the direction of current. How the current flows from the positive and it will come back to the negative terminal. This is what is important. Don't worry about the direction of current right now. I'll tell you when you need to consider the direction of current, direction of flow of electrons. Difference between current and electrons. There is no difference, just that it is convention. We assume that current flows from the positive terminal of the battery and return back to the negative terminal. And we later find out that it is the electrons which are moving, and then scientists did another convention that electrons flow in the opposite direction. We use this convention so that the life would be easy. So you can do a lot of calculations. I'll show you these calculations, okay? Alright, solve this. conventionally the direction of current is taken as the direction of flow of negative charges, direction of flow of atoms, direction of flow of molecules, direction of flow of positive charges. So here atoms and molecules, they do not move. So there is no question of direction of flow of atoms or molecules. How about negative charges? That would be electrons. But we know electrons flow in the opposite direction. So conventionally, they have chosen it to be direction of flow of positive charges. Correct? Yes, Shaina, correct. Awesome. So now I'll explain you this question. So there are 2 points, point A and point B. Point A is at a potential of 10 volt. So this one is at a potential of 10 volt. Point B at a potential of 20 volt. This at a 20 volt. Correct? So what is the direction of flow of electrons? That is a question. Conventional current will flow from higher potential to the lower potential. So here the point B is at a higher potential. This one is at a lower potential. So what is the direction of current? So current will flow, or I is a current. Current will flow from B to A. There is a direction of current. Okay, but what is asked? Flow of electrons. So electrons will flow in the opposite direction. So electrons will flow in the opposite direction. So what is the direction of flow of electrons? It is from A to B. Understood now? Electrons flow from lower potential to the higher potential. Current flows from higher potential to the lower potential. When I say current, this is our conventional or convention that we have chose. Convention is current flows from higher potential to the lower potential, because we want to match, right? I gave you the example of gravitational potential. Water flows from higher potential energy to the lower potential energy. So similarly, current flows from higher potential to the lower potential. Clear? Great. So now, okay, there are 2 points, VA and VB are the 2 potential or 2 points. Which of the following is correct? So you see here, current is flowing from B to A. So what does it mean? Is B at a higher potential or lower? What is the direction of current? From B to A. That means B is at a higher potential. So B is at a higher potential than A. So there is a correct option. You don't have to, I told you earlier, don't have to worry about flow of electrons. You don't have to consider. Just focus on direction of current. That is more important. Where are you from? I am from Pune. Like born and brought up in Pune. So now, clear everyone? Easy, right? Great. So now let's look at the circuit diagram. So why it is important? We cannot, like I cannot show the battery all the time in my circuit, right? So I use a symbol, just one cell. If I have multiple cell, then it becomes a battery. Battery is a bunch of cells, correct? And how do we arrange? There is a positive, negative, positive, negative, positive, negative. This is how you should arrange. The negative terminal of one cell should be connected to the positive. Then only they will add up. Otherwise, they will cancel out. So there is a proper setup, correct arrangement. So now this is a key. So sometimes in your laboratory, you insert the key. So when you insert the key, circuit will be closed. So current will flow. When you open the key, you remove the key. So now no current is flowing through the circuit. Or we have the switch. For example, in our houses we have switch. When the switch is open, that means no current. If you close the switch, then current will start flowing through it. Clear? Now, if the wires are connected to each other, we have a lot of electrical wires, right, going across each other. So if they are connected, we use a junction. There is a joint or the junction. Or if the wires are not connected, But how do we show it correctly? Using this particular symbol. That means one wire is going above another and they are not connected. Now there is a symbol of electric bulb like a heart shape, very beautiful one, and resistor. This is a general symbol for all the electrical devices. You can just use this symbol for the resistance or resistor. Now there is a symbol for rheostat. If the resistance of a device is changing, resistance is not fixed, that is a rheostat. You can use either this symbol or this symbol when the resistance is not fixed. And these are two more devices that we use. This one is for ammeter and this one is voltmeter. So how do we use ammeter and voltmeter? Ammeter we use to measure electric current and voltmeter we use to measure voltage or potential difference. So either you can say voltage or you can say potential difference. We are not interested in absolute value of the potential, not required. You saw in the gravitational potential energy, we choose one reference, one ground, and with respect to that we calculate the difference. So here also we are only interested in potential difference, correct? Either you can choose letter voltage or potential difference, both are correct. So now this ammeter is in series with the cell or with the resistor, and voltmeter is always in parallel. We'll learn about this series and parallel in the next class. So have a patience. So now, what is Ohm's law? There is a very popular law, right? Even after you get pass your grade 10, even after 20 years, you will still remember this Ohm's law. A lot of my colleagues, they are much older than me, but they remember, they are not from physics background, but they know this Ohm's law. So what is this Ohm's law? So Ohm is the name of a scientist. He did some experiment. What was the experiment? He arranged the different batteries and there is a resistance. So across this resistance, he measured the voltage. So it is not the voltage of the battery. It is the voltage measured across the resistor. And he measured the current which is flowing through the circuit. From this circuit, how much is current flowing through? And then he plot a graph. What is this graph? V versus I. He plot V versus I and he found out this graph is going through the origin. This is a straight line. These are very good observation that he did. This is a straight line passing through the origin. So you can say the voltage is directly proportional to the current. The potential difference across the resistor is directly proportional to the current passing through it. So what he did, if V is proportional to I, you can convert the proportionality into equation by adding a constant, correct? So he got this equation, R is equal to V by I. This is called as Ohm's law, this equation, or from here you can write V is equal to I times R. This equation, these are all similar equations, same equations, correct? These are called as Ohm's law, this particular equation. So now what is this R? R is a constant, it is called as resistance and the SI unit is ohm. So people gave some respect to this person. So he said, okay, you take the credit for it. So SI unit of resistance is ohm because of Ohm's law. How it is defined? 1 ohm is 1 volt divided by 1 ampere. So there is the SI unit of resistance. You see this? So there is a voltage guy. He is trying to push the current. This guy who is going through it, that is a current guy. He want to rush, but this ohm guy or the resistance guy, he is stopping. Resistance is like a blocking the current. It does not allow the current to pass through. So now let's understand this Ohm's law in much detail. So if R is constant, resistance is constant, that means voltage is directly proportional to the current. That is our Ohm's law, correct? So now you can get lot of other intuitions from this equation, if let's say current is constant, current flowing through it. You see this diagram, this is like analogy. So if you have lot of water in the tank, and let's suppose there is a tap here, you open the tap, you increase the height, what will happen? The water will come at a faster rate if this height is more. So what is this tell you? This is the voltage. If you increase the voltage, then current will increase. Current, that is the flow of water, will increase. So now what is constant? Current is constant. The water coming from this tap, you want to put it constant. You don't want lot of current to come. You increase the voltage. But now you don't want lot of current or lot of water to come out. So you increase the resistance here. So when you increase the voltage, resistance will increase if current is constant. And now third, if this height of the water is fixed, that means voltage is constant. Voltage is constant. So now you see this small region, that is our resistance. You make it wide open. That means you lower the resistance. So if you lower the resistance, what will happen? Current will increase. So there is an inverse relationship between resistance and current. So there is an inverse proportionality. These are direct proportionality. So there is a direct application, I would say, from the Ohm's law. Clear? Yeah, my Hindi is very bad, so I try to speak in English, but I'll try mix and match Hindi and English, okay? Alright. So now, there is a voltage versus current graph. You plot V versus I. You see, V versus I. So how do you find the slope? So the slope is change in the y coordinate. You know, for any graph, there is a run, and this one is rise. So the slope is given as rise divided by run, correct? So what is rise? Rise is a change in the y coordinate. So what is the y coordinate? Voltage. So change in the voltage or the potential difference. And what is the run? Change in the current, correct? So now you see this graph is starting from the origin. So you can write this as slope as V divided by I. So what is V divided by I? It is nothing but our resistance. So if you have voltage versus current graph, the slope will be resistance, correct? So greater the slope, greater would be the resistance. For example, this green graph has higher resistance because it is steeper, right? The red graph has a lower resistance because it is not that steep. Got it? Understood? But you can plot it I versus V. So like in mechanics, time will be always on the x-axis. But in electricity, you can change. You can either plot V versus I or I versus V. So now, what is on the y-axis? Y-axis is current. On the x-axis, it is voltage. Yes, so what is the slope? Slope will be change in the y coordinate, that is change in the current divided by change in the x coordinate, that is voltage. And you can assume that they are starting from the origin. So you can just write it as I divided by V. But what is I divided by V? It is our 1 by R. So if the graph is current versus voltage, the slope is inverse of the resistance. That means if the slope is higher, resistance is smaller. Slope is lower, resistance is larger. That is the meaning of 1 by R. Slope is inverse of the resistance value. So lot of questions came from this graph in previous year exams. So that's why these are very important graph, both of them, V versus I or I versus V. You have to be very careful what is on the y-axis and what is on the x-axis. Okay. Now solve this question. Repeat one more time. Okay, I'll repeat. Solve this. So how much current will electric bulb draw from a 200 volt source if the resistance value is 100? So potential is 200 volt and the resistance is 100 ohms. R is 100 ohms. Correct. So current would be V divided by R, which is 200 divided by 100, these many amperes. So how much is the current value? Current will be 2 ampere. Correct? Yeah, this one. Okay, I cannot add new screen. Okay, anyways, I'll explain you again this one. So you see here there is a voltage versus current graph. So how you find the slope? Slope is nothing but change in the y coordinate divided by change in the x coordinate. So okay, instead of this I'll draw a simpler graph. There is a voltage versus current and there is a graph. Let's suppose there is a point, there is some V0 and there is some I0. Correct? So now this height is the change in the voltage and this height is the change in the current. This triangle means change. So what is change in the voltage? It is the final voltage, that is V0 minus what is the initial voltage? It is just 0. Correct? Change in voltage is V0. And what is change in current? It is simply I0. Yes? So now how will you write the slope for this graph? So slope would be change in the y coordinate divided by change in the x coordinate, that is V0 divided by I0. And what is V divided by I? It is our resistance. So the slope for this graph is resistance. Correct? So higher the slope, higher will be the resistance. Lower the slope, lower will be the resistance. That's how this graph can be analyzed. Clear? Okay, let's solve more questions. So in an electrical circuit, if the resistance is doubled, what will happen to the electric current? Voltage is maintained constant. So here we know V is equal to I R. So voltage is constant. That means I is inversely proportional to the resistance. Correct? Why? Because voltage is constant. So now if you increase the resistance, what will happen to the current? Current will decrease. If you double the resistance, what will happen to the current? Current will become half. So that is option number B. If you double the resistance value, current will become half of it. Yes. So nu I, I'll write I nu would be proportional to 1 by 2 times R. So there is a 1 by 2 factor here, right? So the new current will be half of the original current. So that is why it is option number B. So now which of the following is the correct form of Ohm's law? So there are multiple options correct. Choose all the correct options. So first option, I is equal to VR, that is not correct. V is directly proportional to the I. This one is correct. And third option, V is equal to IR. This one is also correct. So these are correct forms of the Ohm's law. You can write it in various different forms. These two are correct. Clear? Yes, correct. Shaina, nice. So now the potential difference between the terminals of an electric heater is 80 volts. So I'll write here potential difference is 80 volts, or instead of this we'll just write V is 80 volts. We don't have to write potential difference always. So V is 80 volts. Correct? It draws a current of 4 ampere. So it draws current of 4 ampere. So what current will the heater draw if the potential difference is increased? So now if you increase V to 140 volt, what is the current? So what is constant here? We are using the same heater, correct? It is the same heater. That means the resistance is constant. How will you calculate resistance? Resistance is V divided by I. What is voltage? 80 volts divided by current, which is 4 amperes. So the resistance is 20 ohms. This resistance value is constant, it is fixed. So now use it here. So what is I? I is V divided by R. What is voltage? Voltage is 140 volts. And what is the resistance value? We got just now 20 ohms. So substitute. So it is 20 ohms. So this will come out to be 7 amperes. Correct? So when you increase the voltage to 140 from 80 volts, current will increase from 4 ampere to the 7 ampere. Correct? Nice. Great. Okay. So now these are the different diagrams. A cell, resistor, key, ammeter arranged as shown in the figure. Correct? So the current is recorded in the ammeter would be maximum in 1, maximum in 2, maximum in 3, and same for all the cases. So now current will be V divided by R. So check here. There is the same battery, correct? Same resistance, same battery, same resistance. So will the current be same or different? What do you think? As long as V and R they are same, the current drawn will be same for all the cases. It is going to be same because the battery is same, resistance values are same. That is the reason the current is going to be same for all the cases. Clear? Okay, so now there are two graphs, correct? Graph 1 and graph 2. Two IV graph, current versus voltage graph. So Ohm's law is applicable for which of the following? So for which of the following graph we can use the Ohm's law? That is the question. So what Ohm's law says? Voltage is directly proportional to current, or I can write this as current is directly proportional to voltage. So in the first graph, are they proportional? No, they are not proportional. In the second, yes, current is directly proportional to the voltage. So it is diagram 2. For the diagram 2, Ohm's law is applicable. Clear? Easy? Great. So now we have 15 more minutes. Let's see what we can learn. So there is a resistance. Till now we were talking about resistance, but what happens inside this resistance? So there are electrons which are flowing, but you see there are atoms as well. So when the electron flows, it collide with the atoms, it collide with the other electrons. So the resistance of the conductor depends on length of the conductor, area of the cross section, and nature of the material. So if you increase the length, of this conductor, what will happen? There will be lot of atoms, lot of electrons. So this electron will collide with lot of other atoms. So resistance will increase. So we can say resistance is proportional to the length. When you increase the length, resistance will increase. How about the second one? Cross section area. So now consider there is a small pipe through which water is coming, and there is a large pipe through which water is coming. So is it easier to come from the smaller pipe or the thicker pipe? It is easier for the water to come from the thicker pipe, correct? So that means the resistance is inversely proportional to the area of cross section. If you increase the area, resistance will decrease. So now let's write down these equations. So resistance is directly proportional to the length and inversely proportional to the area of cross section. So you can combine these two. So resistance is directly proportional to length divided by area. This is not current, this is length. So we can add the constant of proportionality. This is called as rho. How will you pronounce? Rho. And what is this called as? This is called as resistivity. It is the property of the material. So based on the value of resistivity, you can categorize different materials. We are going to look at that. Maybe we'll solve a couple of questions and then we'll go to that. Yes, so this rho is called as electrical resistivity, and the SI unit of rho is ohm meter, ohm multiplied by meter. It is a material dependent property. For different materials, the resistivity value would be different. Correct? Yeah. So current will flow more easily through a thick wire or thin wire. I'll try, Sahil, to speak in Hindi. कोशिश करता हूँ, but my Hindi is not very good, so that's why I'm not speaking. So current will flow more easily. कहाँ से easily flow करेगा current? Through a thick wire or thin wire. If it is thick wire, so bigger cross section, तो current बहुत आराम से flow करेगा ना? So it is option number C. Current will flow easily through the thicker wire. Thinner में से क्या होगा? Resistance बहुत ज़्यादा होगा. Water बहुत कम flow करेगा. So same electrical current from the thin wire will not be able to flow easily. ठीक है? So now I'll skip this question. We'll come back to that. And let's understand some material properties. So see, these are the copper wires. Then these are the insulators which are wrapped around these copper wires, and these are called as semiconductors, like silicon chips. So these electrical conductors, they have low resistivity value. And how low? You see, this 10 raised to minus 6, minus 8. These very, very low values of the resistivity. And what are these materials? Copper, aluminium, gold. These are also called as good conductors of electricity. And what are the insulators? They have very high resistivity. You see this plus 12, plus 17. The powers, they are very huge numbers. And what are these materials? Plastic, rubber, glass. They are used for the coating of these conductors. And the third component, which are in between, their resistivity value is in between. They are called as semiconductors. The silicon, gallium, these are all semiconductors used in our computers, laptops, mobiles. All the silicon industry is used, they are using these semiconductors. Okay. So now we have two materials, manganese and mercury. तो उनका resistivity का value ये दिया है. For manganese Mn and mercury is Hg. Manganese के लिए resistivity कितनी है? 1.82 10 raised to minus 6. 1.82 10 raised to minus 6. और mercury के लिए 9.4 10 raised to minus 7. So which metal is a better conductor? तो इन दोनों में से better conductor कौन सा है? Is it manganese or mercury? So here direct comparison is not very good idea, right? Because this is minus 6, this is minus 7, 10 to the power minus 6, minus 7. So we need to first make their exponents equal. So you can write this down as 10 raised to minus 6 into 10 raised to minus 1 multiplied by 9.4. So 9.4 into 10 raised to minus 1, that is divided by 10. So that is nothing but 0.94 10 raised to minus 6. Now you can compare. For manganese it is 1.82, for mercury it is 0.94. So which one is better conductor? The one which has lower resistivity value. So which one has lower resistivity value? It is the mercury. Correct, nice, great. So now resistance of a metal wire of length 1 meter is 26 ohms. There's a long question, so let's solve it fast. Resistance is 26 ohms, length is 1 meter, diameter of the wire is 0.3 mm. So diameter is 3 into 10 raised to minus 4 meters, correct? So what will be the resistivity of the metal wire? So we know R is rho L by A, correct? This is the value of resistance. So from here you can find resistivity. Rho is given as R into A divided by L. R into A divided by L, correct? So substitute the values. So now here we want area, correct? We know the diameter. So how will you find the area? Area is pi r square. So there is a diameter. So radius would be diameter divided by 2. So divide this by 2. So substitute here. So it would be 3.14 into radius is 3 divided by 2, which is 1.5 into 10 raised to minus 4 square, correct? So now substitute the values. How much is the resistance? 26 ohms. 26, length is 1 meter. So just as it is, divided by 3.14 into 1.5 square. This multiplied by 10 raised to minus 8. So solve this and tell me the value. Solve it. So it comes out to be how much? Roughly it comes out to be approximately 3.6 into 10 raised to 8, correct? This is the resistivity of the metal wire. Keep it English, yeah, I'll try. So this is the last question of the day. Let's solve this question. I'll first explain you the question. So battery is maintaining potential difference of 1 volt. So there is a battery, you see it is maintaining the potential difference, but this wire has the resistance. Usually these wires have 0 resistance, but now there is a special wire and it has a resistance. So resistance of the lamp is 10 ohms. There is a lamp which is the 10 ohm resistance, and resistance of the connecting wire is 2 ohm meter, correct? And length of the wire is 5 meters. So now I can redraw this structure. So there is a battery. So there is a resistance of the wire, correct? And there is a resistance of the bulb. They are connected to the circuit. So battery is how much? 1 volt. Resistance of the wire is how much? So we need to calculate. Resistance of the connecting wire is 2 ohm meter, 2 ohm per meter. So resistance of the wire is 2 ohms divided by 1 meter. But what is the total length? Length of the wire is 5 meters. So I have to multiply this by 5 meters. So what is the total resistance? It is 10 ohms. So resistance of the wire is 10 ohms. And what is the resistance of the bulb? Resistance of the bulb or the lamp is given as 10 ohms, correct? So resistance of the bulb is 10 ohms. So now we'll learn this tomorrow, in the next class. How do we add when the resistors are in series? But I'll give you the answer now. When the resistors are in series, you just add them. So 10 plus 10 would be 20 ohms. So there is a series resistance. So now there is a total resistance value in the circuit, and the voltage is 1 volt. Now use Ohm's law to calculate the current. So the current which is flowing through this circuit would be how much? Current is voltage divided by total resistance. Yes, so what is the voltage? It is 1 volt divided by the total resistance value, which is 20 ohms. So this is how much? 1 divided by 20, that is 0.05 ampere. So there is a current which is flowing through it. Current which is flowing through this circuit, that we got 0.05 amperes. So now if I measure the potential difference voltage across the bulb, that is what the question is. What would be the potential difference across the lamp? So how much will it be? So we know the current. How much is the current? 0.05 flowing through it. There is a current and the resistance is this much. So what will be the potential difference across this bulb? So the potential difference would be I times R. So what is I? 0.05. 0.05 amperes multiplied by resistance value, which is 10 ohms. 10 ohms. So this will come out to be how much? 0.5 volts, correct. So this will be the potential difference across the bulb. Usually these connecting wires, they have negligible resistance, but because there is a special wire, it has this connecting wire has the resistance. So out of this 1 volt, only 0.5 will be across the lamp and other 0.5 will be across this connecting wire. So we are losing that much potential. That is the reason we use only the conductors, very good conductors such as copper or aluminium as a conducting wires. So there is no loss in the potential difference. Alright, so that's it for today. Thank you so much. Please join our Telegram channel. You'll get all the notes and the assignment in our Telegram channel. Thank you so much.